Good morning. So today I'm going to be talking about black carbon emissions from stoves and domestic heating that impact the Arctic. This is in collaboration with the Esponte, who prepared the first 2/3 of the presentation, but we decided to have me present since I'm in the room. And we were both pinch hitting for Vigdis, who unfortunately could not attend. So domestic wood burning is the biggest source of black carbon and PM 2.5 in Europe, and it is growing as a percentage of emissions, as I will show. It's one of the sources that is actually less addressed by current policies than a number of other sources, but it's also a politically sensitive issue because a lot of people have emotional attachments to their stoves. It's something that's in their house, their homes, and they're very used to the traditional way of burning. As we've heard already today, BC and OC emitted in the Arctic and near large areas of snow and ice have a larger impact. PM 2.5 policies, if you care about their climate impact, you need to think about strategically targeting those sources with the highest BC component. Of course, reducing any PM 2.5 source improves air quality and human health. So it's never a bad thing to reduce PM 2.5, but if you're looking at climate mitigation, BC-rich sources are important. And so we see here in the dark blue line, that's total BC emissions over time. This is from the EASA gains model. So the good news is that BC emissions have decreased and are projected to continue decreasing over the near future. However, we can see here in orange is residential combustion. So back in 1990, it was about 30% of total BC emissions. I think this does not include wildfires and agricultural burning. And transportation, particularly diesel vehicles, was the largest source of emissions in 1990. We have been very successful at addressing BC and PM emissions from diesel through the use of, in large part, diesel particulate filters. And so as that blue bar shrinks over time, then a larger and larger percentage of the remaining emissions are coming from residential combustion. So this was not necessarily the first source that we wanted to address, but as we address the other easier sources, residential combustion is going to become a larger and larger component of the remainder. And so we will need to think about how to address this in the future. This chart shows emissions by country as a percentage of total BC emissions. So you can see there's a lot of variance country to country, but it is a substantial component in many countries. And then in some countries also some of this combustion in residential stoves actually comes from non-biomass sources. It actually comes from coal or lignite or peat. And so that's also a factor. As we know, Arctic Council has been established for several decades and began discussing SLCPs in 2007. So Esponte was present for those initial discussions, as was Ben D'Angelo in the room. I came onto the picture in 2009 for the task force on black carbon, methane, and ozone through the Arctic Council. And so, you know, we've been looking at this for a long time. We have our black carbon goal And so we want to think about how now residential combustion can be a part of this. A larger number of countries are part of the UNECE, LRTAP, and importantly, the Gothenburg Protocol, which has been addressing PM 2.5 for a while, has now begun to include more black carbon emissions. The Arctic Council started including BC emissions inventories in 2015 for the expert group on black carbon and methane. LRTAP has been moving to making that a sort of more regular submission. The IPCC is being inspired by LRTAP in terms of coming up with black carbon emission protocols that will apply more globally. And the executive body of the protocol did adopt best practices for solid fuel burning. And so this guidance document is a potential target for updating in the future to improve guidance in terms of the black carbon emissions. So there are sort of 3 targets in terms of reducing black carbon emissions from residential stoves. The first is to take existing stoves, and you can actually reduce emissions even from existing stoves by improving the usage of those stoves, whether it's fuel, whether it's better ignition practices, making sure that the ventilation and the maintenance is all appropriate. So this is sort of burn right campaigns can be done without actually needing to change any physical infrastructure. And I seem to remember in some expert group meeting, I think our one of the Danish representatives discussed how they worked with chimney sweeps to identify which chimneys were seeing the most deposition of soot, and then they would go and talk with the homeowners from those houses to provide them with literature on maybe how to do things better. That has a limited potential. You can get something 30 to 50% emissions reductions, but the real way to sort of reduce, especially BC emissions, is to use new improved stoves. So there are a lot of low BC and PM 2.5 stove technologies that exist. Some are pellet stoves, some do use whole logs. There's been a lot of black carbon testing protocols that have been developed through the Nordic Council. Nobody really has BC standards yet, but there are potentials. For example, there's the new Eco Design Directive for space heaters. And so that's an opportunity as that gets updated to really bring in this black carbon story and the PM story. I think at the moment that directive, for example, has some NOx directives, but the problem is that when you're doing biomass burning, your ability to reduce NOx emissions is limited because a lot of the nitrogen is actually coming from the fuel, but there's a lot of potential for PM reductions. And then the question is, how do you provide these incentives? Can you do subsidies for new stoves? I know in some states in the US, when you sell a house, that's when the stove requirements can trigger. So you can't sell a house with an outdated stove. You either have to remove the stove or install a new stove. Can you ban really dirty stoves even in sort of existing houses? So there's all sorts of different methods that have been applied, and we need to learn how to make these methods both as effective as possible and as politically palatable as possible. And then the last is fewer technology switches. So actually potentially moving away from wood burning stoves to electric heating, to pellet stoves, I know in some countries there's a lot of these what's the heating system where you sort of have the pipes that carry the hot. Yeah, the heat pumps, but also there's some cities where you have these sort of geothermals.
District heating.
District heating was last thinking. Yes, but geothermal heat pumps, these are all valuable technologies to be thinking about as we move forward. Just general energy efficiency, so you don't need to burn as much to heat your house. There are some other stoves, so there's still use of coal stoves, as I mentioned. So that's a really good target because that's going to have higher emissions of PM, BC, and CO2 than other sources. There have to be considerations made for stoves that are used for both heating and cooking. Heating water is also important. And some of the poorest households have some of the largest emissions. So thinking about how to address those issues are important. So finally, I want to present 2 slides on a study that I was a part of, looking at Arctic temperature impacts from residential stoves in Europe. And I'm calling this a case study because I think there's a number of ways in which the study can be improved and expanded, but I think there's some valuable lessons to learn from our approach in terms of doing both analyses on stoves, but also more generally. So first we used the EMEP stove emissions data from 2016, and then we looked country by country. So the y-axis here is black carbon emissions per gigajoule energy produced. So all of the countries at sort of the top of this bar are high BC per unit activity, and therefore potentially good targets if you're looking at reducing climate impacts. The size of the circle shows the total BC emissions from stoves from that particular country. So again, you can use this combination of circle size and circle height to really be strategic about targeting. And then we took all of this and we used this surface temperature response algorithm from Maria Sam's work in 2015. Which sort of related temperature impact of the Arctic to emissions by region around the world. I would love to see an update to that work that would count the new IPCC science, the new AMAP science, and maybe do like a latitudinally based, because we talked about, David Bolton talked about this 40-degree sort of cutoff. So I think that could be improved. But we see here that in terms of 2016 emissions, the largest climate impact comes from these conventional stoves. That's the second bar. Boilers on the far right also have a net climate impact. This is considering both black carbon and the cooling impact of organic carbon. So that's an important factor sometimes to consider when you're thinking about net climate impacts. And it divides the BC impact from snow and ice deposition from its atmospheric impact. So that also shows how important that snow and ice factor is. So on the left, we have the existing climate impacts with the X showing the net. On the right, we did sort of a thought experiment. What if we took all the stoves and turned them into high efficiency stoves or advanced stoves or pellet stoves, then one of the interesting findings here is if you move from conventional stoves to sort of the high efficiency stoves as defined by the EMEP protocol, you do reduce PM. So it's an important air quality benefit, but you actually don't reduce the climate impact because you disproportionately reduced organic carbon emissions. So even though you have some reduction in BC, the reduction in OC basically cancels out your climate benefit. So you don't get much of a change. And remember, these are big aggregate categories. Every stove type is different. So there's, I know, a lot of work being done to really characterize stove by stove their BC and OC and other emissions. And so for specific stoves, you'll want to look at that. But the advanced eco-labeled stoves and the pellet stoves both dramatically reduce PM emissions overall and reduce BC emissions sufficiently that overwhelms the co-emitted cooling pollutants. So you really do get this climate benefit of moving from conventional stoves to these eco-labeled or pellet stoves. And we calculated that you could get a couple thousandths of a degree benefit in the Arctic from doing this kind of conversion just by looking at the 14 nations that we picked out for this study. So if you included Canada, Russia, the US, and other European countries, you could get more substantial. So I would love to see sort of this kind of study be applied more broadly, both with updated surface temperature impact response functions, better emissions inventories, and not just to residential stoves, but to other options. So we have this question of, targeting. What stoves do we target? What are the best replacements? Improving the science, and most importantly, really thinking about the measures to actually enact these replacements in the real world. So with that, thank you for listening. And Visvante, who's obviously an expert on black carbon in the Arctic and has been part of this community for a very long time, is also available to answer any questions. Thank you.